Lesson 3. The representation of the Cartesian product. Question 1. If x equals 1 and 2, y equals 3, 4, and 5, find the Cartesian product of the two sets x and y and represent it by the arrow diagram, second by the Cartesian diagram. So first we write the Cartesian product x multiply y, which equal set of ordered pairs 1 and 3, 1 and 4, 1 and 5, 2 and 3, 2 and 4, 2 and 5. Now we will represent this Cartesian product using arrow diagram. Here we have the set x and the set y, and we write the elements of x 1, 2, x. Of course we write x first, and y and its element 3, 4, and 5, and we join each two elements to represent the set of ordered pairs. Here we have 1 and 3, 2 and 5. We have how many arrows? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 arrows. Here 1. Now we have the arrow diagram. Then the Cartesian diagram. We write the elements of x here and the elements of y in these two rectangles. Here we have x and y. What is the elements of x? 1, 2. The elements of y 3, 4, 5, and we draw a net. One and 4, 1 and 5, 2 and 3, 2 and 4, 2 and 5. Here we have 6 points. Here we have 6 arrows. Here we have 6 ordered pair in the statement of the Cartesian product. Second question here. Question 2. If x equals 3, 4, and 5, then find the Cartesian product x by x and represent it with an arrow diagram. So we write x multiply x, which equal we have 3 and 3, 3 and 4, 3 and 8, and we start again with 4. 8 and 8. How many ordered pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 3. And then we'll draw it in arrow diagram. We write the 3 elements So we have the first ordered pair is 3 and 3 here, 3 and 4, 3 and 8, from 3 to 8. Then 4 and 3, 4 and 4, 4 and 8, 8 and 3, 8 and 4, 8 and 8. Notice in the figure the Cartesian product of infinite sets and its graphical representation. First, the Cartesian product of n by n equals x and y such that x belongs to n, y belongs to n. It is a natural number. It is the natural numbers. Here, let us discuss this question. Draw a perpendicular graphical net and represent the set of natural numbers n on the two horizontal and vertical straight lines. Then identify the points A 0 and 4, B 4 and 0, C 3 and 2, and D 5 and 3. So we draw a vertical line and horizontal line. Here we have x and y. Here we have the elements of the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, and so on. And we write x here 0, 1, 2, 3, 4, 5, and so on. Here we have y. The point A of coordinates 0 and 4. 0 and 4. Here this point is 0 and 4. B 4 and 0. Notice that the 2 points A and B are not equal. C 3 and 2. So start from 0, 1, 2, 3. Then up 2 steps, 1, 2. So here C of coordinates 3 and 2. D 5 and 3. Again start from 0. 1, 0, 1, 2, 3, 4, 5, 1, 2, 3. Here, the point D. 5 and 3. Second, the Cartesian product of z multiply z. Z, of course, is the set of integers x and y. It is any point in the plane such that x belongs to z and y also belongs to z. Here we have the intersection of the two horizontal and vertical lines is the point 0 and 0. In z we have all the positive 1, 2, 3, 4, and the negative 1, negative 2, negative 3, negative 4. Also here we have 1, 2, 3, and so on. Here we have negative 1, negative 2, negative 3. It is the set of integers. Here also the set of integers. Here in this example, identify the ordered pairs which represented by the points A, B, C, and D in the opposite graphical net. Here is the point A. To find the coordinates of the point A, we start from A. Here using like this. So the coordinates of the point A 2 and 3. We start with x 2 and 3. The point B, we start with x coordinate. It is 3 and negative 2. the point C, negative 3, negative 3 and 1. The point D, negative 3 and negative 4. Third, to represent the Cartesian product Q multiply Q, we know that Q, it is the set of rational numbers which equal A over B, such that A belongs to Z, Z is a set of integers, and also B belongs to Z. In condition B not equal 0, because division by 0 is meaningless. So Q multiply Q equals a set of ordered pairs X and Y, such that X belongs to Q and Y belongs to Q. So draw a perpendicular graphical net and represent the set of rational numbers Q on the two horizontal and vertical straight lines. Then identify the points A, 3 and 5 over 2, the point B of coordinates negative 3 over 2 and 4, C negative 3 and negative 3 over 2, D 5 over 2 and negative 3 over 2. So we have the horizontal line and the vertical line, and then we represent the point 3 and 5 over 2. So we start from 0 and count to 3. So we have 0, 1, 2, 3, and then up to 5 over 2. 5 over 2 equals 2.5. So we go to 2.5. So in this location, we have the point A of coordinates 3 and 5 over 2. The point B, negative 3 over 2. Negative 3 over 2 is negative 1.5. So we have the point B of coordinates negative 1.5 and 4. So start again from 0. Negative 1.5 lies between negative 1 and the negative 2. And up to 4 here. So here are the coordinates of the point B. Negative 3 over 2 and 4. C, negative 3 and the negative 3 over 2. Negative 3 and the negative 3 over 2 here. Here is the point C. The point D, 5 over 2 and 5 over 2. We start from 0. 2.5 equals 5 over 2 and the negative 3 over 2. Negative 1.5. So here is the location of the point B. Fourth, representing the Cartesian product R multiply R. R is the set of real numbers. So the Cartesian product R multiply R equals a set of ordered pairs X and X, such that X belongs to R. So X in a real number and Y belongs to R. Okay. Now let us take some points. First, you have to remember that N equals 0, 1, 2, 3, and so on. And Z, it is the set of integers equals 0, 1, 2, 3, and so on. And the negative numbers, negative integers, negative 1, negative 2, negative 3, and so on. Q is the set of rational numbers. Q. Here we have some rational numbers like negative 2 over 3, 3 over 2, 0, and so on. All of these numbers, and also you can say 5, it is a rational number because 5 equals 5 over 1. It is rational numbers. And we have the set of irrational numbers, Q dash, like root 5, it is irrational number. Root 10, it is another irrational number. Root 3, and so on. Okay. When we say root 9, it is rational number, not irrational. Root 9 here equals 3, and 3 is a rational number because it's equal 3 over 1. We can put it in a fraction in the form a over b, but root 3 you cannot write it as a fraction in the form a of b. Okay. Okay, what's the relation between Q and Q dash and R? R equals Q union Q dash. Okay, when you collect all the numbers Q and Q dash, you will get the set of real numbers. Okay, back to the graph. Here, draw a perpendicular square net. Okay, like this, of the Cartesian product R by R. So here we have R, the set of real numbers here, and also here all we have the set of real numbers. Okay. Now, then tell the quadrant or the axis where each of the following points is located. The point A of coordinates 3 and 3, here 3 and 3, lies in the first quadrant. Here we have first quadrant, here we have second, third quadrant, fourth quadrant. Okay, here always we have x is greater than 0 and y is greater than 0. I mean x is positive and also y is positive. In second quadrant, we have x is less than 0. Always x coordinate is negative. And y coordinate is greater than 0, is positive. In third quadrant, x is less than 0 and y also is less than 0. In the fourth quadrant, we have x is greater than 0 and y is less than 0. Okay. Okay. Here, a equals 3 and 3. You can put it in the quadrant. Here we have the point A of coordinates 3 and 3. And you can say that A lies in the first quadrant. What about B? 3 and negative 2. 3 and negative 2. Here, 3 is positive, right? X is positive, y is negative. So the point B lies in the fourth quadrant. Here, x is less than 0 and y also is less than 0. So the point C lies in the third quadrant. What about D? Negative 4 and 3. It lies in second quadrant. Here, 0 and negative 3. 0 and negative 3. You can say it lies on the negative part of y-axis. Okay? 2 and 0. 2 and 0. Here, the point F. 2 and 0 lies in x-axis, the positive part of x-axis. If x equals negative 1, sorry, x equals the interval -2 and 3. Find the location which represents x multiply x. -2 and 3. So -2 and 3, from -2 to 3 on x-axis here, and from -2 to 3 on the vertical axis. Again, from -2 to 3 on the horizontal axis. How we represent x multiply x? Like this, from -2 to 3 on the horizontal axis, from -2 to 3 on the vertical axis. Here we talk about interval. So to represent this Cartesian product, we use this rectangle here. All this rectangle. It represents x multiply x. Okay. Now let us answer this question. Show which of the following points belongs to the Cartesian product x multiply x. A, 1 and 2. Where is 1 and 2? 1 and 2. Okay, so you can say that 1 and 2 belongs to x multiply x. 1 and 2, the point A. 1 and 2 belongs to x multiply x. 3 and the -1. Start from 0. 3 and the -1. Here. Yes, you can say that the point B of coordinates 3 and the -1 belongs to x multiply x. It is closed interval. Okay, so it contains -3 and also contains it contains -2 and also contains 3. So the point B will be here, B, on the edge of the interval, but it is exist. The point B is 3 and -1. The point A, it is inside it, here. The point A, 1 and 2. 1 and 2. The point C, -1 and 4. Point C, -1 and 4. Here, it is out, right? The point C of coordinates -1 and 4. So you can say that C of coordinates -1 and 4 doesn't belong to the Cartesian product x multiply x. The point D, -2 and 0. -2 and 0. -2 and 0. Here it is -2 and 0. Lies on the edge of the interval. So you can say that D of coordinates -2 and 0 belongs to the Cartesian product x multiply x.